Now the power circuit of an office is supplied at 240 volts and has the following appliances connected to it. It's got 4 heaters rated at 3000 watts and it's got them on for 5 hours. It's got 1 kettle at 2000 watts for 0.5 hours and it's got 5 computers at 1000 watts for 6 hours. If the charge per unit is 7 pence, what would be the total charge for the day? What would it be? Well, first of all, what would be the resistance of each item and what would be the total effective resistance of the whole circuit? So let's determine the first part of this question. Let's determine the total watt hours used. Well, the heaters would use 4 times 3000 times 5 hours is 60 kilowatt hours. The kettle would use 1 times 2000 times 0.5 is 1 kilowatt hour, and the 5 computers would use 5 times 1000 times 6, 30 kilowatts an hour. So this would give us in total 91 kilowatts an hour, and 91 times 8 is £7.28. That's what that would be. Now I want to determine the resistance of each item. Well, in order to do this, firstly we need to determine the current running through each appliance using this formula. Now P equals VI is the formula. Now if you transpose this, you get I equals P divided by V. So let's determine the current through the heater. Well, we know that I equals 3000 divided by 240, it's 240 volts. This gives us 12.5 amps. So that's the current running through the heater. Through the kettle, it's I equals 2000 divided by 240, gives you 8.33 amps. And the current through the computer is I equals 1000 divided by 240, it's 4.17 amps. Then we determine the resistance of each item using the following: V equals IR, which you can transpose to make R equals V divided by R. They determine the resistance of the heater, R equals 240 divided by 12.5, 19.2 ohms. The resistance of the heater is 19.2 ohms. The resistance of the kettle, R equals 240 divided by 8.33, is 28.8 ohms. And the resistance of the computer is 57.55 ohms. The final part of the exercise was to determine the total effective resistance of the circuit. Don't forget, these are in parallel, so you have to use this formula. 1 divided by R equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. If you put them in, now don't forget there's 4 heaters, 5 computers, and this is reflecting the formula. This is the formula, and it comes out at 1 divided by R equals 4. Don't forget there's 4 heaters divided by 19.2 plus 1 divided by 28.8 plus 5 divided by 57.55. This gives us an effective resistance of 1 divided by R equals 0.33. Therefore, the effective resistance of all of it is 3 ohms. That's 3 ohms.